Hello and welcome to another edition of Developer Skills Sprints. I'm Nick Hodges, Senior Software Engineer at Viva Systems, and today I'm going to be talking to you about aspect-oriented programming with DSharp. This skill sprint works with just about everything inside of Rad Studio and App Method. The only thing I'm holding off on is the C++. This is a purely Object Pascal sprint, but otherwise it should work with Windows, OS X, Android, iOS, throughout Rad Studio and App Method. I want to remind you that you can take a look at the Rad Studio XE7 doc wiki as well as the App Method 1.15 doc wiki on those links below. Skill sprints work like this. I give a little introduction, then we go through some code and demos, discussion, and then we have a live Q&A at the end. And this is just a general reminder. You can always download the free trial of the current version of Rad Studio and App Method at embarcadero.com/trial download. Okay, so what is aspect-oriented programming? Well, it is a method of separating out concerns. Any good software developer knows that clean code involves the separation of concerns, and that's one of the things that aspect-oriented programming does. It's a way of implementing what is commonly called cross-cutting concerns, like logging, security, and validation, etc. Logging is a good example of something that can happen almost anywhere within your code, but that is something that you don't want to necessarily include in all of your code. You don't want to include it in every single class. You just might want to include it in some. And so aspect-oriented programming allows you to insert it in the side, if you will, as opposed to up and down from an inheritance level. It allows you to slide it in from the side. Security is another good example. Should someone have the ability to execute a specific method? Well, you don't want to have to worry about that for every method in your entire code body, but you do want to worry about it in some places. So aspect-oriented code, it will allow you to insert cross-cutting concerns in a horizontal manner. Aspect-oriented programming tells you a few things. First, it can tell you that you've entered a method. It can tell you about any parameter values at the entry of the method. It can tell you the result of any function call. It tells you that you've exited from that method, and it can also let you know when an exception is raised. You can add code at the entry and exit points, and you can call code when an exception gets raised. This is the basics of what aspect-oriented programming does, and it allows you to alter the code that gets executed without actually having to change the code itself. There's really no better way to understand it than to take a look at a quick demonstration, and we'll do that right now. Okay, for our very first demo, we're going to look at what is the basis for the DSharp Framework's aspect-oriented programming framework. And that is the Virtual Method Interceptor class. The runtime library in the RTTI unit includes a class called the T Virtual Method Interceptor. And you'll never guess what it does. It intercepts virtual methods. So here we have a very simple class called VMI Demo class. It has two methods on it, a function and a procedure. One does something and the other raises an exception. Now below here, you'll notice we have three standalone methods, a do before, a do after, and a do exception method. Each of these things just simply writes out basic information to the console. The real work gets done in this main function, which creates an instance of T Virtual Method Interceptor, passing in the class type that will be intercepted. You can then at that point assign to the on before, on after, and on except methods the three methods that we declared above. And finally, you proxify the instance of the class that you've created. That is, you wrap a proxy around it in order to allow the T Virtual Method Interceptor to do its work. From there, you can call the methods on the VMI demo class. I'm going to call both do something, passing 42, and raise exception. And then you can see the do before, do after, and do exception methods at work. So we'll simply run this, and you can see that yes indeed, before do something, doing something is the message of what the do something method actually does. And then after something has a result of 42. You can see we set the result in the doAfter method. Then we went into the before raise exception, and an exception was raised on purpose, and we simply pass that exception on to the onException handler, which writes it out here. That's an example of the virtual method interceptor class at work, allowing you to control what happens before, after, and on an exception. A couple of things to note here. First of all, you can decide that you don't even want to invoke the method at all. That'll allow you to do things like not execute code if a person can't enter the correct password, or if there are certain situations where you don't want the method to be run for whatever reason. You can also have the exception squelched if you want to by saying raise exception equals false. So now if we run this example, you'll see that the before do something method is still called, but the return result is a 0, and we didn't execute anything inside of the do on before method. And also with the raise exception, nothing happened. The exception was not raised, and then the work was not done in that method either. So that's the foundation upon which the DSharp Aspect-Oriented Programming Framework is built. Alright, so given that, the DSharp Framework includes a unit called DSharp.interception. Interception is the basic idea of wrapping up the notion of the tVirtualMethodInterceptor class into a much easier and more straightforward way of doing what we saw in the last demonstration. So in order to do this, we'll give the example of a logging behavior. And the logging behavior is going to descend from interfaced object because it's going to implement the iInterception behavior interface, which has a pair of methods on it, invoke and will execute. It implements both of these methods first by invoking the actual method that is going to be proxified or wrapped up. It can grab the method name from the input parameter, say we're entering into that. It can list out all the arguments. It actually here invokes the method itself. It then says that we're exiting the method, and it writes out the known result, if there is one. In the will execute, we'll just simply say true, which means that the actual invoke method will be called. And here's simply, again, the implementation of the tDoSomething class. In this case, it's just do another thing for the do another thing method. The do something method takes a string and says hello to whoever, whatever is passed in. You'll notice the three things again are the logging behavior implementation of the iInterception behavior method, an iDoSomething interface, and the implementation of that called tDoSomething class. So if I run this application, you'll see that indeed the entering do something method is called. There's a single argument called skill sprint attendees. That's right from the code. We're doing something, which is the actual implementation or execution or invocation of the method. We're exiting the do something method, and the result is hello skill sprint attendees. And again, when we call do another thing, we just simply enter and exit with no result because it is a procedure. This is the basic idea of interception. This occurs in the main function, which simply creates an instance of the tDoSomething class as a iDoSomething interface. Then it calls the tIntercept class through a proxy, and it passes in that instance, and it passes in the behavior that we want to implement on that particular class. From there we can call methods on the logged class, as you can see. We can call the procedure here as well as the function both, and we get the result that we saw earlier. This is very similar to the proxify method that we called earlier on the tVirtualMethodInterceptor class, though it allows you to much more easily process the beginning and the end code that wraps up the actual invocation of the method itself. So that's an example of basic interception in the DSharp framework. Now for this next demo, we'll have a very similar application in structure. However, we will use our ability to intercept the actual execution and invocation of the method to do a little work and check to see if someone is authorized to change a salary. So here you should see the same three basic members: the interface iSalaryChanger, which has a procedure change salary, a class implementing that interface, and then a behavior, a security behavior that implements again the iInterception behavior interface. That iInterception behavior interface will have an invoke method that looks like this. We'll first write out, enter the password, and we'll ask the customer or the user for that password using a readline. If the answer is sprint, that's the secret password, so don't tell anybody, then we will begin by writing out successful login and we'll actually execute the result. If the password is wrong, however, we'll tell them, sorry, wrong password. Result will be nil, there will be no result, and the execution of the change salary method will not occur. If everything goes well, you should see the message, you changed the salary because you were authorized to, by having the change salary method actually be called. Now this all happens because we have a variable called SC of type iSalaryChanger. We call the TIntercept class the through proxy method, passing in as a generic type the interface, an instance of the salary changer, and an instance of the security behavior as well. Now you notice the security behavior is an array. That means you can actually have more than one behavior if you wish. But that's beyond the scope of our demo now. So if I run this application and I enter the password SPRINT, you'll see successful login, and I was allowed to change the salary. However you wanted to make that salary change work. However, if I run it and I enter in foobar, you'll notice it says sorry, wrong password, and nothing happens. The method is not invoked. So this is an example of using interception to do some work and actually decide whether or not the method is going to be invoked based upon user input. Well, that's all well and good. That works. The interception methods allow you to control the entry and exit points of a method, allow you to decide whether to actually execute the method or not. But if you want to put that type of code into your application, it could get quite tedious having to place all that boilerplate code all over the place. And anytime there's the notion of putting boilerplate code all over the place, you should think attributes. And of course, the DSharp framework includes an attribute class that allows you to descend from it and provide the invocation logic that will attach itself via attributes. So here's a simple example using our security notion. First of all, we have a handler attribute as a parent class to our security attribute, and all that does is call a function called createHandler. The TSecurityHandler class is a descendant of the TCallHandler class, which implements the iCallHandler interface, and it has an invoke method on it. And this is the place that we will include our logic for checking to see if someone can successfully log in. If they can enter the method successfully, that is, they can enter the method and pass in the correct password, then we go ahead and have a successful login and invoke the method. And then we leave the method with a true message. If not, the result is nil, and we leave the method with a false message. Hacker, you've been thwarted. So this application then becomes quite simple. We simply have an interface called iBankTransfer, which augments the Ionvocable interface. That's required. We tag it with the security attribute, and we try and transfer money. We then implement a class using that interface. We use the intercept class to create a proxy via attributes for the iBankTransfer interface, and we pass in an instance of the class that we want to proxify, and then we just simply transfer the money. If the money is transferred successfully, you'll see this message right here. So we can run this, and the password is, once again, sprint. So we can run this, type in the secret password sprint, and you can see we were successfully logged in. We transferred $453 and an entry of your activity was logged, just like we expected the methods to be called. If we run it and we type in the wrong password, it says, hacker, you've been thwarted. And all of this can be reused throughout all of your code simply by using this unit here, the use security attribute unit, and attaching the security attribute to any method where you want the user to have to enter a password. This is a much simpler and much more straightforward way of implementing aspect-oriented programming than would be the boilerplate code that you would have to use as we saw earlier. Here's one final example of how aspect-oriented programming can be used with attributes to make your code simpler and provide a separation of concerns for something along the lines of a WeightCursor. You can use aspect-oriented programming to provide a very simple way to have a WeightCursor appear when you want it to. In order to do that, again, we descend from handler attribute, creating WeightCursor attribute, and we simply call an instance of tWeightCursor handler, which descends from tCall handler, which again implements iCall handler. In our invoke method, all we do is wrap up the execution or the invocation in some code that wraps up the invocation with a change of cursor. This is by storing the old cursor, change the cursor to an hourglass here, and then execute the code, and then finally change it back to whatever the cursor was before. Very simple, very straightforward way. We've created a long process here that has the WeightCursor attribute attached to it. We implement that interface, and the long method simply sleeps for 5 seconds. I've also created a simple form here, and it creates an instance of the long process through the intercept proxy by attributes call. You pass it the interface that you're implementing and an implementation of that interface, and then you can simply call the long method on it, and your cursor will change. So let's show this running. Simple application. Pops up, and for 5 seconds the cursor will be the WeightCursor. 1, 2, 3, 4, 5. Very simple. And now, by using this WeightCursor unit in any of your applications, you can have a WeightCursor attached to a method that you know will require it. This is another example of using aspect-oriented programming to slide things into the side, as opposed to implementing them through an inheritance tree, which would be much more complicated and much more invasive. We'll wrap things up and then move on to the question period. So in summary, aspect-oriented programming allows you to separate your concerns in a cross-cutting fashion, horizontally as opposed to vertically. It gives you access to the methods as they start and as they end. It saves you from using a lot of repeated boilerplate code via the attribute feature, and the DSharp framework provides an interception code on attributes to easily do aspect-oriented programming. Here's some AOP resources real quick. The DSharp Framework is available on Bitbucket at the URL shown there. The code and slides for this demo are available at that bit.ly link with Nick AOP at the end of it. And the Aspect-Oriented Programming Wikipedia article is actually a very good resource for information about aspect-oriented programming as well. Up next in the Sprint Developer Series is a preview of the Enterprise Mobility Services, an overview. Marco and JT will be doing that, and I strongly recommend you take a look at this new feature of XE7. It's quite powerful and quite easy to use, and I'm very impressed with it. And I recommend that you attend the Enterprise Mobility Services Overview Developer Sprint. You can always follow Embarcadero at Embarcadero Tech on Twitter, And you can download the free trials at the URL down at the bottom of the slide there. And now it's time for questions and answers.
Question about the branch of DSharp you're using.
I was on the Caliber branch when I did the demonstration, but I believe everything I showed will work on the develop and the master branches.
Okay.
Wait, give me a sec, Jim. I was very remiss in not mentioning the fact that DSharp was written by Stefan Glenke, the guy who now has also taken over the Spring framework. Stefan's brilliant work is the thing that enabled me to do this demo, and I was remiss in not mentioning his name and thanking him for the DSharp framework.
Excellent. And what is DSharp free?
DSharp is completely free, open source license. I believe it's released with the MIT license. You could check that on the page that I showed there that's on the screen right now, the Bitbucket link. Let me go there. Okay.
When was DSharp Framework released, and when was it support for XE7 added?
Support for XE7 comes naturally. There's nothing special that needed to be done. I believe the first check-in of the code was in April of 2011, so it's been around for three and a half years.
And so how do you install it into XE7 then?
I download the code from Bitbucket using Git, and then I add the paths to the source into my IDE manually. There isn't a way to just install it.
Okay, so you should add the paths manually.
Yes.
Do you know if there's plans by Stefan to integrate DSharp into Spring 4D?
Yes, I believe the exact interception stuff that I showed that we showed in the demo is moving and migrating over to Spring 4D. As a matter of fact, it is in a branch on Spring 4D. Although I would have used it, but there is no attribute support yet. And so I wanted to definitely show how attributes can be used for aspect-oriented programming, and there's no support for attributes yet, but there will be. And so you could look to the Spring framework for the same exact kind of code, slightly different, modeled after a different code base from the C# community, but it's the same principle, and look for it soon to have attribute support.
Okay. Good to know. Can you use DSharp to invoke methods if your code doesn't use interfaces?
Depends. I'm going to say no, that you can only invoke interfaces. But actually, I didn't try it. I always code with interfaces. So
Okay.
I believe the answer is no. I believe you need to use interfaces. You need to wrap your class in an interface to get it to be intercepted and proxified by the DSharp framework.
I know I was watching this. From previous skill sprints and such, you've talked about always coding interfaces, so I wasn't sure if that was a requirement of DSharp or if that's just a requirement of Nick Hodges. Might be both, it sounds like.
Always code against interfaces, not against implementations. That's my motto.
So here, Robert Love has a question about what the performance overhead is of using AOP.
Yeah, I really don't know. Obviously, there's some performance because you got to execute the code. I don't imagine it's too much. The framework itself is rather thin. All you're really doing is putting a pretty thin wrapper around the execution of your specific methods that you identify with, that you tag or whatever. So it shouldn't be too big of a hit, I wouldn't think, but I confess I can't say with great certainty.
So Jens has a question here about what is with inheriting from the Ionvocable interface for?
Ionvocable is simply the I interface with method info wrapped around it, providing runtime type information or method, the method info for the interface in question, and the DSharp framework simply requires that to do its work.
Okay.
So I'd recommend doing all of your interfaces, sending all of your interfaces from Ionvocable, because there's quite a few frameworks that you may run across that require it. For instance, Delphi Mox requires Ionvocable interfaces in order to work, in addition to DSharp.
And as you said before, you should always code against the interface and not the implementation, right?
Always code against an interface and not always code against interfaces and not implementations.
So even though, is that required for DSharp, or is that just a good practice?
It's required for DSharp to descend from an interface that's Ionvocable. I see Giovanni says that it works only for virtual methods, but that is true of T virtual method interceptor, only intercepts virtual methods. But the DSharp interception framework will intercept any interface method. So you need to have a interface in order to intercept using the DSharp framework. An Ionvocable interface, I should say.
Another question says, this seems rather complicated. What is the real advantage you get from doing this?
The advantage is the ability to insert code into your current code base without having to expand it with inheritance. A good example is, like a logging system. You could very easily write a logging system using aspect-oriented programming and say CodeSite or Smart Inspect or some other tool, and you can place that in your code wherever you want with an attribute, rather than having to write boilerplate code every place you want to do logging. So say you're working in an area where there's a bug or something and you want to log and see the incoming and outgoing information is, for whatever reason, you can just simply tag that with an attribute and you get logging for that method without having to write any more code. It's a pretty powerful technique, and allows you to insert code into whatever, your code base without writing a lot of code.
Right.
And code reuse as well. You write it once and you can reuse it anywhere.
Right. Yep. I liked how you mentioned that it's the cross-cutting concern. So the idea is that logging isn't something, it's separation of concern. Since logging is not part of your transaction concern for your transaction code, you shouldn't have logging code in that unit. So you completely remove it.
Right. Like a customer class shouldn't be concerned about how to read and write customers, but you could use aspect-oriented programming to do that. I see Jens makes a good point. Caching is a good idea for AOP as well. You could cache results and then retrieve them later the next time a call is made. That's another good example of using AOP, and I think I actually have an example of that in my demo code on Bitbucket, but I didn't have time to show it during this presentation.
So that's a good idea. Very cool.
Yeah, I think there's a demo of using a really inefficient prime number generator to cache results for a specific, not number generator, number checker, and you can type in a big fat prime number that takes a long time, and you can store those off using aspect-oriented programming and then cache the results. I think I have a demo of that.
Okay, that makes sense. So we just look at the parameter and say, hey, I've already calculated this number. I don't need to calculate it again.
Exactly. Yeah, you just store it in the dictionary or something.
Yeah. Very cool.
Did you answer that question about older versions of Delphi that can use DSharp? I might have missed it.
Yes, we Delphi. I'll look this up. Delphi 2010, I think, is the earliest version you can use. I'll look it up for sure and tweet it or something.